Okay, so this is Module 1B lecture, and what we're going to be doing today, excuse me, is we're going to be talking about what geography is and what it isn't, the major themes in geography, and then we're going to be looking a little bit at the physical context for geographic study, and we're going to do a little bit of an overlap with what you'll be doing in your map module. And so remember, you have story maps to work with that will be for your quick write assignment. That story map and that assignment is going to deal with the physical context. And so what I want you to do is take a little bit of what we say today and use that in that project as well. So what is geography? Well, first of all, let's talk about what geography isn't. Geography is not the memorization of capitals. It's not simply the location and names of countries, although we need that as kind of a background. And again, it's not the location and names of physical features. Those are all things that we use as a shorthand. Of course, if we want to talk about rivers, we do kind of need to know where they are and what their names are so that we can talk to each other. It's kind of like having scientific notation in math, or it's like having scientific names in biology. We need to have some of that background. All right, so what it is, and again, I know this is going to sound like a crazy sentence, but it's the study of what's, the wheres of those what's, and the whys those what's are where they are. Now again, probably one of the worst sentences that I could write, but it's a really important way of understanding this. Geography is the study of phenomena. All disciplines study something. The strange thing about geography is that it can study any phenomena, but it is the study of phenomena. Most importantly, though, it is the study of the distribution of those phenomena. In other words, the where of those what's. In other words, where does something occur and where doesn't it occur? How extensive is its distribution? Is it really only found in one place or is it found throughout the world? And then we ask the question, why? Why are phenomena found where they are and not? What factors, what processes lead to that? So in a sense, we really think of geography as what we call a methodological discipline. That is, it can study anything. It can study jazz, or it can study coniferous forests. It can study food, or it can study wildlife. But it looks at why certain things occur where they do. Okay, so let's think about that now. So here's an example of a phenomena. The yellow circles represent microbreweries in this region. That is, locations, establishments that make beer. You'll notice that that distribution is not uniform. In other words, there is some clustering, and that it also doesn't exist in a number of places. In other words, we've got whole areas right through here where there are no microbreweries, and then right here, there's quite a few. Right here, there's quite a few. And then we have one right up here and one right here and a big gap. Well, we can also say that we can look at the distribution of non-discrete phenomena, and we can say alcoholic beverage spending in 2016 by county. And in this area, we see that we have very high alcohol spending in two areas, and then actually quite low here. Now, if we look a little wider, this is most of North America, we see that microbreweries, in fact, cluster quite a bit here, and you'll notice that this seems to be clustered in areas of higher spending. And where there's very low spending, there's almost no microbreweries. So now we have phenomena, microbreweries, and alcohol spending. We have the distribution of those, certainly not random or uniform, but somewhat clustered. And we might say that the distribution of microbreweries is somewhat related to somehow that alcohol spending might influence where those microbreweries are, or vice versa. All right, so when we talk about geography, broadly speaking, we're going to talk about 5 big themes. First of all, we do want to talk about space or location, place, not to be confused with space or location, but place, human interactions with the environment, the movement of phenomena, how things move through space, and they move in a couple of different important ways. And then finally, what this class is really about, which is putting a lot of this stuff together and understanding this in terms of regions, distinct areas that have certain things in common. All right, so let's take a quick look at all of these. So if we talk about space or location, what I want you to understand is that location is the where of something. Now we can talk about where of something in terms of its latitude and longitude. That's an absolute location. Where is it on Earth? Or we can talk about location in terms of relative location. It's 5 miles from something else. Grove City is 11 miles from Slippery Rock. That's the relative location of Grove City in the context of Slippery Rock. We can also talk about space in terms of its actual physical extent. So what you see here is drive time areas. How far from Slippery Rock can you get in 5, 30, or 60 minutes? And those are in fact areas. Locations are where Slippery Rock is, the spatial extent of a 30-minute drive time. Now, place is distinct from space. Place is the characteristic of a location that is unique. And so, for example, this is downtown Slippery Rock. And what you'll notice here is that we see that it's a small town, and there are many of those, but somewhat unique in that it has characteristics of, there's a Sheetz, which kind of helps you say, well, you're in this part of the country. There is the Camelot, which is absolutely something that's known to Slippery Rock University. It's a small diner, very old, very traditional diner. And then you have North Country Brewery. The name North Country comes after a trail, a national hiking trail that runs east to west through this area. And so all those things, in a sense, add to the placedness, make Slippery Rock unique. We can go kind of larger, and we can say Pittsburgh, the place characteristic of Pittsburgh, is influenced by cultural aspects. So, for example, in this upper left, you see that's a Piemonte sandwich that very distinctly has French fries on the sandwich. I'm not from here. It was a very strange idea. But Pittsburgh is also economically associated with, for example, with Heinz and early manufacturing Steelers, the Steelers as a athletic team, and then its neighborhoods. All of these things make Pittsburgh unique in terms of its place. And in terms of place, we understand that as an important part of geography, what makes this place different from that. Okay, now then we can talk about human-environment interactions. And what I want to point out, this is a model, if you will, an hourly flow anomaly. In other words, above average and below average flows in streams in our region, and you'll notice that it's a time lapse here. But what's important about this is not just that it's stream flow, but that stream flow is this interaction between humans and the environment. In other words, human beings have a great deal of difficulty occupying floodplains. They do it, but there's great risk involved. At the same time, floods or flooding, stream volume, is influenced by what human beings do to the landscape. The more we build up a landscape, the less permeable the surface is, the greater the potential for flash flooding. So that's interactions between humans and the environment in a landscape. And then, of course, we have movement. Human beings move. In fact, many things move. This is just an example of one we will look at later on in the semester, and this is about day and night movement. In other words, the squares here that are red indicate populations that are largest during the daytime, in other words, work or labor populations, whereas the blues are those areas that have a larger population at nighttime, and those are residential populations. Now we can also look at movement globally. And what you see here is a world migration map, and this is kind of where people come from and to. Blue dots meaning net in migration, red dots meaning net out migration. And if we look at just the United States, you'll notice that we get migrants from all over the world, but we're getting more and more. You'll notice we have these very rapid inflows, for example, from China, and from India, and from Latin America. We can also, though, look at Syria, and you'll notice that Syria has a substantial, the world's largest out-migration right now, but that out-migration is very, very different, and it's very localized. So a very different way of understanding movement. Okay, so movement, and then we have that last one we'll get to at the end, which is the idea of regions. But before we get there, what we have to do is get a basic understanding of the tools of geography. And I want to start, at least in this first module, with the idea of maps. And we have to begin with the, if you will, the not map. And that is the Earth as it is. This is the Earth from space. And you can see that the Earth is, in fact, a sphere. And in that, everything is, in fact, its correct size. The problem with that is that it's really hard to put a globe in your pocket. And so what we recognize is that we make maps, and maps are two-dimensional representations of space. When you read the text, you'll notice that the text talks about latitude and longitude, and I can tell you right now, there will be basic questions on that on the quiz. Understand what latitude is, understand what longitude is. The other piece, though, is that maps distort. Okay, maps distort. That means when we flatten it out, flatten out the Earth, we're going to distort the shape and size of things. And so if we look at this, this is the Earth as well, but it's flattened out into a rectangle. And the question becomes, what does that do to features on the map? Well, what we're going to do is we're going to look at this in terms of what we call the true size. So this is a true size tool. And what I want to do is I want to give an example. It's the same projection. Projection is the way that we flatten out the Earth. And we're going to look at Greenland. It's kind of the classic one here. And so Greenland, okay, is this piece of the Earth right up here. And on this type of projection, this is what's known as a Webb Mercator, the problem with the projection is that it makes things towards the poles really, really big. And so I'm going to drag this down towards North America. And what we're seeing is that that's the true size of Greenland relative to the United States. Now I'm going to flip this around so you can see this the other way. And I'm going to grab the United States and I'm going to bring it up into Greenland. And you'll notice how that distortion happens. Both the shape and the size of the United States is radically changed. That's what maps do in terms of distortion. We look at this map, and I'm going to clear it for just a moment and put Greenland back on it. And perhaps one of the great stories of this, I want you to look at Greenland, and then I want you to look at the continent of Africa. And on this map, the way it looks, Greenland looks just about as big as the African continent. When I drag it down and do it in actual proportion, you'll notice how small Greenland is relative to the continent. So we have to remember that distortion when we look at maps. Okay, so now we're back to our map and we look at this and we accept that in fact Greenland up here is going to fit right into here, and that's map distortion. Now we can try different things to make it work better, and here's a map that breaks up Earth into triangles, and it does a lot of good things. In other words, here's Greenland, and you'll notice now that it's about the right size. But in order to make this work, we've had to make things not align in terms of the direction. We've changed all sorts of directions on this map, and it's really hard to navigate with it. Alternatively, we can do some kind of compromise where direction is kind of messed up. In other words, this is south going this direction here, south going this direction here, south going this direction here. But you'll notice that size is better, but there's also some distortion of shape out on the edges. So we're always going to distort shape or size or direction or distance. We can't maintain all of them. Okay, so we have this tool, the map, and now let's take a look at this idea of the physical context. When we talk about regions, what we have to kind of start with is the idea of the physical context. In other words, what is the context that human activity occurs within? And what I want you to think about is this in terms of two big themes and then two related themes. Tectonics and how it relates to physiography, climate and how it relates to biomes. So tectonics are earth processes that move crustal plates around and interact. As a result of tectonics, we get mountains, valleys, volcanoes, earthquake systems, much of the uplift that produces then erosion. I shouldn't say much, all of it is essentially the result of tectonics, and it results in our physiography, which is our landform features. Climate is precipitation and temperature over the long term. If we take climate, we can then say the physiography. In other words, some of the landscape is also a result of things like precipitation, erosion, weathering, movement of sediments. And climate also, though, influences where things live and what kinds of things live there. And that, in a sense, is a simplistic way of understanding biomes. So, if we look at this then, and what I'm going to do now is we're going to open up our map document, or our web map, and we're going to look at it in the context of these 4 concepts. So, here is your exercise, and I'm going to go through it real quickly, but I want you to understand kind of what we see. And when you do the activity, you can look at some of these things in detail. But what I want to begin with is this idea of how we see the Earth and how that landscape is important to our understanding, that the global landscape is important to our understanding of regional geography. So let's begin with the idea of tectonics. Now, what is important about tectonics is that it represents how Earth... Again, we're going to talk about tectonics in terms of how plates move, and we have 3 basic movements that are worth understanding. And again, you can take physical geology, you get this in much, much greater depth. But what I want you to focus on from the reading is the idea of a divergent plate boundary, and we're going to see this right here, this is a mid-oceanic ridge. And then we have a subduction zone. This is where we have an oceanic plate going underneath a continental plate. See these arrows here. And then we have a convergent continent-continent plate here. Now I point out those 3, so you'll notice this is up in India, Indian kind of Chinese border. This is in the middle of the southern Atlantic, and then along the Pacific coast of South America. So let's take a look at these in that we talked again about 3 areas, and I'm going to kind of zoom around and look at them. First of all, we talked about this idea of the mid-oceanic ridge, and we're going to zoom in, and we're going to see this ridge line that runs all the way along the middle of the Atlantic. And what's actually happening here, and you can see it almost unzipping kind of, is that each one of these lines is where the ocean plate is diverging. In other words, this part's moving this direction and this part's moving that direction. And so that's one type of plate boundary. Now I'm going to jump ahead and we're going to look at both earthquakes and plate margins. And so you'll notice that this is a diverging plate margin, and there's not a whole lot of earthquakes that at least recently are occurring here. But let's take a look now on that next one, which was a subduction zone, and that's right here. And you'll notice where this plate is going underneath this plate. This plate's more dense, thinner, it's oceanic plate, and this is less dense, and so the oceanic plate goes underneath. And you'll notice all along this type of plate, this where you have subduction going on, we have quite a bit of earthquake activity. All right, and this is actually what we call the ring of fire along the Pacific. Now, we also have, though, convergent plate boundaries, 2 plates running into each other. And perhaps the most famous of these is right here, and that is where the Himalayas are produced. Now, I want to zoom in a bit on this one, because what you'll notice is that this plate boundary right here is a convergent plate boundary, and if I look at it from a landscape standpoint, it's also the highest part of Earth. This is where this piece of landscape ran into this one here, and that produces high mountain chains. So areas of high topography are often produced by this type of convergent plate boundaries. Okay, now let's go back about tectonics then. We can also put in context climate. So we've got tectonics producing the physiographic environment, and then we have climate producing the biotic environment or interacting with it. Again, they're not one-way streets. They're actually quite interacting. And so again, climate we're talking about is simply precipitation and temperature over long periods of time. And that is influenced by some factors that, again, in this class we're going to talk about very, very simply. When we talk about climate, the first one is relatively easy, and this is what we call the Köppen-Geiger climate classification system. It's simply a way of grouping climates into certain categories. But what we can see is that the simplest way of understanding temperature is latitude. The farther you get from the equator, the colder it gets. And in fact, the more extreme your temperatures can be. Then we also have air masses. And what that means is, again, where does the air mass come from? If it comes from an oceanic environment that's warm, you're going to get warm, wet air. If it comes from an interior area, in other words, inside a continent that's a desert, it's going to be drier and it tends to be somewhat colder, especially if it comes from the upper latitudes. Now that gets us to the concept of continentality, meaning that, again, the farther you are from water, the drier the air becomes. Elevation, we've probably all experienced this, the higher in elevation you go, the colder it gets. Well, we also, though, have mountain barriers, and mountain barriers, very importantly, have the ability to produce interior deserts. And so one of the important ideas, and I want to just focus right here, is that in the United States, when an air mass comes off the Pacific, it runs into the Sierras here, or the Cascades, and on this side, that's called the windward side, where it's coming from, it's very, very wet. Think of Seattle. But on the interior, this area here, all of the rain essentially has been squeezed out of the air because it's gone over the mountains, and we have an interior desert. We have the deserts of the Southwest. Now, those mountain barriers then produce windward and leeward effects. Lee effects tend to be very dry, windward sides tend to be somewhat wetter. We can also say that ocean currents affect climate. For example, and again, the United States is a good case study here, we have an ocean current that runs up along Alaska and then down the west coast of the United States. That means that all along this coast, it is extremely cold water, relatively cool water, that influences the climate of, for example, San Francisco. You don't want to go swimming in this water, it's really cold. In contrast, on this side of the country, we have a current that runs northward, comes out of this area, and in fact, it's very warm water coming along the Atlantic coast, which moderates the climate there considerably. Lastly, then, we have what are called pressure systems, and that means that we have, for example, right at the equator, or around the equator as the sun moves, we have a low pressure system, and that low pressure system means there's consistent precipitation, and we can see that throughout this region here. We also, though, have mid-latitude cyclones, pressure systems, that move right through here, and that produces our kind of mid-latitude weather. So climates then produce, to a large degree, biomes. So you'll notice that associated with that equatorial wet climate, we have tropical rainforests. Associated with high latitude environments, we have tundra and boreal forest. Mid-latitudes, we have grasslands and deciduous forests. Each of these is a relationship. Now, as you read the text, and again, I'm not going to get into these in great deal into these lectures, we're limited in terms of what YouTube will allow, but I want you to think about those relationships as you read and then as you explore on the web map. Now, the last point for today is that concept of region. What I want you to begin to think about are these divides. How much do these divides, in other words, our world regions for this class, how much do those make sense in terms of the physical context, or where do they not? What makes these regions regions? Okay, that's it for Lecture 1B. Remember, read the text before you take your quiz.